the answer key for stoichiometry problems number 4, STP gases. You have to have at least seen the lecture on moles of a gas notes, and so now we know 3 understandings of the mole. If we have a pure solid, pure liquid, or pure gas, and information is given us in grams, or we're looking for grams, we can do mass over formula weight. If we have a solution, we have to take our molarity, which is like our concentration, and multiply it by our volume, but our volume has to be in liters. And now we know if we have moles of a gas at STP, and we're going to pretend we're always at STP for right now, you take your volume, again in liters, and put it over 22.4. So as we go through this, I suggest you pause the program on each one, give it a try, and then watch and see if you've got it right. So for the first one, check and see if it's balanced. And it is indeed balanced. And so the question says, what volume of hydrogen gas would be produced if I had 28 grams of zinc? So when you look at this and you're saying, well, what can I find moles of? You should look here first and realize that if I use a formula weight, I can figure out moles of zinc. So I'm going to take 28 and divide it by 65, which is the formula weight of zinc. And when you punch that in your calculator, you get 0.43 moles of zinc. Now, the second step, you always look at your coefficient ratio, trying to get to here. We're looking at a 1-to-1 ratio, and now I know that I have 0.43 moles of gas. Now the question here, though, I guess I should say H2, because now I have moles of H2. Now this question says volume, and you can see that there are 2 that have volume in it. So how do I know which one to use? Well, this one says that this is a gas, so ding ding, this one wins. So moles equal volume in liters over 22.4. And so what we're going to do is we're going to just call that 22.4. I multiply each side by 22.4, and you get 0.963, and that comes out in liters of your gas. So for number 2, I'd say pause it, balance it, and answer the question. Number 2, calcium carbonate will decompose to form carbon dioxide and calcium oxide. What is the volume of carbon dioxide gas that will be produced at STP if I have 152 grams of calcium carbonate? So again, I can find moles of calcium carbonate. I'm going to take the mass divided by the formula weight. 1 calcium, 1 carbon, and 3 oxygens. When you do that math, you get 1.25 moles of CaCO3. Now, because it's balanced as written, that is another 1-to-1 ratio. So I also have 0.52 moles of CO2. They said that this is a gas. So again, I'm going to do the exact same thing I did up here, and I'm going to set that equal to volume in liters over 22.4. Your answer then is 34.05 liters of carbon dioxide gas. All right, number 3 is going to throw you a different curve, so I suggest you pause the program, try to figure this out on your own. All right, for number 3, it is already balanced, and it says, according to the following equation, what mass of hydrogen peroxide would be needed to prepare 29.4 liters of oxygen at STP. Now, a lot of people will say, hey, yes, I can find moles of oxygen, so I'm going to take 29.4 and put it over the formula weight of O2, which is 32. That is absolutely wrong. Why? Because we have liters here. Okay, I can't put liters over formula weight. If I have liters of a gas, I need to put it over 22.4. So common mistake that people make. So if you did that, go back and erase it. We want to divide this by 22.4. Pause the program and try that again. When you get that, you get 1.39 moles of O2. Now, tricky ratio here. I have this, which is a coefficient of 1, and I'm trying to find hydrogen peroxide, which is a coefficient of 2. So I actually have a 1-to-2 ratio. So I'm going to double my moles. Okay? Now that's how many moles of H2O2. What did it want to know? It wanted to know the mass. So now I'm back to our first equation. Moles equal mass over formula weight. X formula weight of 16 and 16 and 2 would be 34. When you do that, your pops out in your calculator 0.898. What unit is that if I'm looking for mass? Got it. Grams of H2O2. Pause number 4 and give it a try. Alright, so this one's a little tricky. Sulfuric acid is here. I do not know the molarity, but I know we have 10 milliliters. I do not like that. Let's turn that into liters, shall we? And we also have the amount and the molarity of our sodium hydroxide. 1, 2, 3. 2 zeros there. So now when I'm reading this, I see volume, I see molarity, I want molarity. I know that these are both solutions. So I'm going to use this equation twice. That's all you needed to get started. Pause the program and get started. Alright, so the first thing I know the most about is moles of sodium hydroxide. I'm going to do its molarity times its volume in liters, and you get 0.0025 moles of NaOH. Now, we have a 2 to 1. 2 to 1, I know this, my question mark is here. 2 to 1 mole ratio, so I'm going to divide that number by 2. And I kind of rounded this. You can keep it out if you would like. Now, what does the question ask, though? It says I would like to know the molarity. So I know moles equal molarity times volume in liters. So what do I know? I'm looking for molarity. We know the volume, got to make it go into liters. You just divide both sides by 0.01. Divide this by 0.01. And you get 0.13 molar sulfuric acid. Alright, so on to the back. It says consider the following balanced equation. Answer the questions. I try both of them and then come back and see how you're doing. Alright, how many liters of carbon dioxide gas, so this is my carbon dioxide, be very careful, would be needed to react with 15.75 grams of iron oxide. So I have Fe2O3. I have a mass, so I divide it by its formula weight, which is 160. When you do that, you get 0.098 moles of Fe2O3. I'm going from here to here, and so that is a 1 to 3 ratio, so I'm going to multiply that by 3. So that's how many moles of CO2. Now the question though asks me how many liters of carbon dioxide gas would be made. So I'm going to do this as equal to x over 22.4, multiply both sides by 22.4, and you're looking at 6.5. What is the unit going to be for that? Good, liters of CO2. Now you can see you have the exact same amount here, so just pull that number down. Try to answer what mass of iron metal would be produced. Alright, so I'm just going to take the same number of moles because we're starting with the same amount. And I'm going from here to here. This is a 1 to 2 coefficient ratio, so I'm going to double my moles. Now, if that's how much iron I have, the question says what mass. I'm going to equal x over the formula weight of iron, which is 56. But remember, coefficients, number on the front, do not affect formula weight, so I just have 56. Multiply that, and you're going to get 11.2 grams of iron. All right, pause the program. Try number 7. All right, it is balanced. I'm trying to give you a tricky ratio here to see what you do with that. I want to know what volume of oxygen gas is required for the complete combustion of 75 grams of octane. Okay, octane being right here, so the first thing I know the most about octane. I can divide 75 grams or the formula weight of octane. When you do that, you get 0.66 moles. Now, for the tricky formula weight, I'm going from a 2 to 25. We can divide that, that's like a 1 to 12.5. So I would multiply by 12.5. So my moles is 8.25 moles of oxygen, and the question says what volume of oxygen gas are required. So you're going to x over 22.4. You're looking at 184.4 liters of oxygen gas are needed to burn up all of that fuel. All right, last one, I say write and balance the equation. A couple things. It says that it is a combustion reaction. It gives you your hydrocarbon. Try to pause the program or write and balance that equation. Alright, so the first thing when you have a combustion reaction is you write your hydrocarbon. What does everything need to burn? Oxygen gas. And what do you produce? Carbon dioxide and water. And you could have written this in any form or fashion. What do you first look at when you're balancing combustion reactions? You look at your C's and H's first. So I see 3 C's, so I'm going to put a 3 in front of here. I also see 8 H's, so I'm going to put a 4 in front of here. Now let's look at how many oxygens we have. 3 times 2 gives me 6 oxygens here. 4 times 1 gives me 4 oxygens, so I have 10 oxygens on this side. So what do I need in front of VO2? 5. Now, it says, at STP, what volume of gas would be needed to react with 20.69 liters of propane gas? So if I want to find moles of my propane gas, and I have liters of my propane gas, please do not divide it by its formula weight. You've got to divide it by 22.4 because it's a gas. And you're going to get 0.12 moles of propane. So we're going from here to here. That is a 1 to 5 ratio. So I'm going to multiply that by 5. Looking at 0.6 moles of oxygen, and it wants to know what volume of that gas. So X over 22.4, 13.44 liters. See if you can't pause the program and finish this up. Alright, so I have the same amount of gas, so I'm going to keep that there. But now I want to know what volume of CO2 gas is going to be produced. I have a 1 to 3 coefficient ratio here. Multiply my moles by 3. And again, it wants to know volume. So I'm going to multiply that by 22.4. Stop the program and see if you can't finish the last one. Alright, again, take the same amount, but this time we want to know about what volume of gas. So I'm going to go 1 to 4 coefficient ratio. Multiply this by 4. It wants to know the volume. Multiply each side by 22.4 and you get 10.75 liters. Hopefully you're feeling good with all these problems. Bring in any questions you have for us.